Similarly, in case of other things, you will see either there is gravitational force existing behind that very particular thing, or there is electromagnetic, or in case of nucleus, there are two other things: strong force, strong nuclear force, and another is weak nuclear force. So that means all the forces which are we observing in our day-to-day life, these come under four category of the forces, and those four forces are fundamental in nature. There is no further reduction in that very thing. That force has no further source. That's itself the primary source. So that's why these are called as the fundamental forces. And there are four fundamental forces inside our universe right now. Although there is dark energy, dark matter, which are having different domain, and maybe there is something else, there is some another force behind that, but that is not our domain of physics, which we are discussing right now. So leave that very portion aside. But basically we are dealing with the physics, which is well established. So in that regard, we have four forces of nature, four fundamental forces of nature. First is the gravitational force. First is the gravitational force. About the gravitational force, this is one of the, I can say this is the most ancient discovered force to the humankind. It was known to the humankind centuries and centuries back. Okay, so humankind, man was knowing about the gravitational force very much from the very much beginning, but this gravitational force is most complex in nature. It is not yet understood completely. Okay, so this is most mysterious gravitational force, this most mysterious force among the fundamental forces of nature. So this is I can say this was well known to man many centuries earlier, many centuries back. So about the gravitational force, since we are dealing with right now, we are dealing with the classical physics, classical mechanics, or classical or Newtonian mechanics. So I will not get into these gravitational forces so much deeply that you will get diverted to some other stuff. So we will deal with the Newtonian mechanics only. In that regard, Newton himself gave an expression about the gravitational force. So gravitational force, which is one of the first part of our fundamental forces, F, this gravitational force is given as equal to gm m by r square. What does that mean? With a minus sign. That means if we have two masses, say for example m, capital mass here, and a smaller mass, or maybe they may be equal size, that doesn't matter anything, that doesn't change anything rather. So here if we have two masses and the distance from their centers is r, distance between these two particles, two systems, two masses is r, then Newton says that, Newton's law of force says that the force existing between these two particles, these two systems, is given by force is directly proportional to the product of their masses. That is, G is directly proportional to the product of their masses, and inverse proportional to the square of the distance between them. That is the square of the distance. Distance is r. So this is also called as the inverse square law. Inverse square law, because it follows force inversely proportional to distance between the two masses, and the radius or r, which is the distance between the two particles, it is from this very center to this very center. So this very force is also known as the central force. I write here the central force. Okay, so it follows inverse square law, and gravitational force is given as equal to minus gmm by r square, where m is mass of one body, small m is the mass of another body, and r is the distance between them in the center. What does this between their centers, what does this minus sign indicate? This is very simple. Minus sign indicates that F, that is, which is gravitational here, I will write it down subscript as G. Gravitational force is attractive in nature. Attractive in nature. Attractive in nature. So that is attractive. Whenever there is a kind of attraction between the two particles, the force which is existing between them, we indicate that as negative, because negative indicates, for example, take a body here which is mass m, this is the center, and another mass, say it is here. If we locate this very point with respect to this mass, bigger mass, this is smaller mass, as some radius, or we can say some position, this is called as the position vector, or position vector. This is called as the position vector. You will come across this further in the subsequent classes. So if this is the vector, position vector of this very point, of this very mass, then the force existing is gmm by r square. But what is the direction? Since it is attractive, so this very particle will have a force heading towards the bigger mass, towards this very mass. So we have seen that the position vector is heading towards this, that is r is heading towards this, but the force of attraction, force of gravitational force, is heading opposite to it. Since these two are opposite, this opposite nature is indicated by a minus sign, indicated by negative sign. This is the significance of minus. Otherwise, if you put no minus there, it won't change any physics. Just you have to remember that the gravitational force is attractive in nature. And there is some G here. This G is called as gravitational constant, or universal constant, whatever you can say. Gravitational constant. Gravitational constant. And its value is given to be, it is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg. Per kilogram square. How this is calculated? This is simple. I will show you shortly here. So for that, what you have to do, look, we have force is equal to, keep aside this minus sign because minus is with no units, g mm by r square. We have to calculate the units of g. Units of g. Look, g is equal to, cross it, this will come down, this will be written as f multiplied by r square divided by, on the m and m comes on this side in the divided form, so it will be written as m. So g will be equal to, from this g will be equal to f multiplied by r square divided by m. into m. What is the unit of F? Units. Unit of F is Newton, which is represented by N. R is the distance between the two masses, that is the distance, and the unit of distance is meter, but it is squared. So Newton meter squared per or divided by m. M is mass, small m is also mass, and the unit of mass is kilogram. But this is mass into mass, that is kilogram into kilogram, that is kilogram square. So this comes to be the units of G, the gravitational constant. So this was the basic, the fundamental force, first fundamental force, which is the gravitational force, and it exists between gravitational force or simply gravity. We can call it gravity as well, gravitational force, but that has its own domain. You have to recall that also. Gravitational force, where it is applicable, it is seen on the whole of the universe. It is seen everywhere, between the stars, galaxies, planets, even our solar system. This is sun and this is our planet, the earth. This is revolving around the sun, and that is also based on gravitational force. Okay, so this gravitational force, it has range of infinite, we can say, because it is seen everywhere. Even though it is small, it is very much weak force, but it has a longer range.